So in the last class, we were talking about this. About this class methods and static methods, all that. Today we jump to a new topic altogether, that is constructor in Python. So the constructor topic in C++ or Java or C# is slightly different from the constructor what we have in Python. Of course, the concept of constructor is same. The way we implement constructor here is slightly different. Okay, friends, see here. So what is constructor here? So this is nothing really. Just a minute, friends. Yeah, sorry, my slight disturbance. So just fixed it. So constructor, what is this? So this is not something really we don't know. It is something like any other methods. We know methods, right? We have instance methods, static methods, class methods. But finally, a method is nothing but it performs some task, whatever method it is. Even constructor is a special function. Generally, you know why we use constructors is it is used to declare and initialize instance variables of a class. So this is exclusively used to initialize instance variables. Earlier, you know, right, we had discussed about instance methods, instance variables, about object, how variables are stored in object, all that. That variables which are stored inside object, right? So we try to declare them and initialize inside instance method. But that object initialization, we generally do that with constructors. So that instance methods we don't generally use for initializing object, but we use constructors to do initialize objects, right? Of course, if you use it, there is nothing wrong in that. But the point is, constructors is something which is important, which is used to initialize object. I mean, used to declare and initialize instance variables. So that is what the exclusive purpose of constructors. So what is a constructor? Constructor is a special function used to declare and initialize instance variables of a class. And second thing, like methods, if it is any method, we should call it explicitly. We have to call methods so that they get executed. But you don't need to call constructors. Constructors are automatically called when our object is created. I hope this is clear. So that is another important point. So this is the idea about constructors. Apart from that, see, simply speaking, only there is a slight change in the syntax. Otherwise, the way we declare constructor is like declaring any other method. That's all, friends. So you don't need to think that this is something new for you. That syntax is something new. Other than that, the way we declare it and declare instance variables and initialize them is almost same as what we did in our previous sessions. Okay. So generally, if we talk about constructors, again, we have two types, default and parameterized constructors. We know we had already discussed about functions, default functions, parameterized functions. Okay. Likewise, we had discussed with examples as well. Okay. Similarly, if we talk about constructors, We have two types of constructors, default and parameterized. If you see the syntax here, this is how it is. Let's start with default. This is the example of a default function, default constructor, sorry. This is syntax of default. You can see constructor means it is something we declare with init, with the underscore, double underscore at as prefix and suffix for init. And this is how it should be. This is more like a built-in kind of thing. We cannot declare as we like. It should be like exactly same, right? So if it is in Java, constructor should be same name as class name, or C sharp even, it should be same. But here, constructor is not having same name as class name. It should be, this is the constructor, init is the constructor. Okay, so now this is how you define a default. You don't need to have any other parameters except self. And self is nothing but an implicit pointer. Pointer in sense, when you print and see self, it holds address of that particular class itself. Got it right? It's like a this pointer or a this keyword in Java or C sharp, which points to the current class object, simply speaking. That is self here. And if you have idea about those languages, if not, just remember, self is something which points to current class object. I'll print and show you if you want to know that. So that's about constructor, right? It has same, it is it doesn't have same name, of course. It is a special function which is used to initialize exclusively instance variables of a class. Maybe you can ask a question. We have instance methods, right? Why can't we use instance methods? Technically, methods are used to implement some kind of business functionality, some kind of logic. Not methods, instance methods. If you want to implement some kind of database connectivity, if you want to implement some kind of mathematical logics, in all that cases, or any kind of logic, then instance methods are used. But to initialize instance variables, then exclusively we are provided with these constructors. And default means it is a constructor without any parameters, local variables. In brackets, you don't see anything except self, right? This is the default. Right? Let us see an example. So you can see, you can take the example of book. So book has parameters like name, author, price. You can take any example of your choice. It's not like you should take book itself. Okay, if you think you like something else, you can choose that and use the properties, book name, author, price. Another important point about constructors, a constructor doesn't return any type except none. So like in like methods, you know, right, any method, instance method, a static or class, they can return something, but constructors can't return anything. So this is actually the design. This is in the design of constructor. If you ask why means, so that is how constructors are designed by the Python people. Even same thing is applied in Java and C Sharp or C++, I believe. So these are important points to remember. What is that? Constructor is automatically called when our object is created. We prove all these points step by step. It doesn't return value. And the exclusive purpose of constructor is to declare and initialize instance variables of a class. That's all. And let us do a small example of working with constructors, both default and parameterized. We'll work on that. That closes the foundation of OOP. Because this is the basic of object-oriented programming. If you have really understood what is class, what is object, relation between class and object, then with constructors, that foundation will be completed. And other topics doesn't take much time if you have really understood all these things. Okay, now let's go to the topic. What is that? Constructor. Okay, test. So now you can take class book. You write class name. Now, like in other languages, we can't directly declare and initialize instance variables. So we have to use either constructor. Sorry, friends. We have to use either constructor or some method to define instance variables in Python. So we use constructor now. Let's replace that instance method approach. This is more standard way of doing that initialization. So def underscore underscore init, you can see here, self. This is construct. This is a kind of built-in, right? So now, what properties we can declare here? Book name, book price, and book. You can add book yeah, that has some ISBN number or something. That number. Okay, you can add that. Okay, so now our number of pages, you can add all that. So now you can just start self dot name equal to, this is hard coding. We are just doing a hard code, but this is not recommended in programming. We change that, right in the next example, we change it to the parameterized approach so that we don't need to hard code our variables. So self dot name equal to something like, you can take any book of your choice. Okay, Harry Potter, right? And self dot price. You can take something like price equal to some 1,000 rupees. Okay, and self dot, if you want, you can add some ISBN number. Okay, equal to anything, some 1, 2, 3, 4, 5, something like this. Okay. So this is a simple. What difficulty is there in this, friends? This is simple, right? Only thing you should remember, this is how you define constructor. That's all. Other than that, we discussed functions once. Spent at least 3, 4 sessions exclusively on functions. Again, when we started classes, we discussed how to add a method to a class, instance method to a class, how to add instance variables to that method. All that we discussed. So again, we are just only changing that instead of regular instance method, we put in it. That's all. Rest of these things are same, almost similar. And this is constructor. This is how it look like, and it is exclusively used to initialize instance variables. By now, you should know these are all instance variables. If someone asks you, how can you say they are instance? By looking at self, you can recognize, okay, these are instance. Right, friends? So this is how you define a constructor, and this is how you initialize, define instance variables. Okay, I just defined something. Let's print this. Use a method for that, def get book. Okay, or print book. It's up to you what name you want to choose. Give some meaningful name to that method. That is enough. Okay, so next after that, just you can say print. Okay, you have colon, and then what is that you can do? The name is, you can simply say self dot name. That's all. Similarly, you can try for printing remaining two books, remaining two properties. The price is okay, and the ISBN is okay. So ISBN dot price, ISBN number, sorry, self dot price, ISBN number. So that's all, friends. See here, self dot ISBN number, self dot price. This is how you should print, and this is over. This is how we just define a simple book, right, friends? This is the idea. Now, what is that we should do? By now, you know, we created a class, and all these are instance members, including constructor. And if this method should be called, before that, what is that we should do, friends? All of you know that. What is that? Once class, we create class with instance methods or instance variables. Second step is we know we have to create object. So create object, and how do you do that? Something like book equal to that class name parenthesis. This is the default constructor. So we don't need to pass anything in this object, right? So when object is created, automatically this is called. We put a debugger and test it. We'll do that, right? So this is creating a book class. So first thing, creating object. Next after that, what is that I should do? If it is normal instance method, we should explicitly call that using object reference or object. But this time this is constructor. You don't need to call that. That constructor is automatically called. Second thing is get book. What is that you should do? The here you have to say that book ref book dot get book. Okay, that's all over. Simple, right? So this is how you create a simple program. What is that? Step one, you have declared a class, used constructor to initialize instance variables, use a method to display all that instance members, and then create an object. Step two, create an object. Step three, access the methods of class. Yeah, and we don't need to call constructor. That is why we didn't call constructor. Now right click, run this. Okay, we are debugging, right? So what happens? See here. I'm let me run in debug mode. See this. You got it right. Now go to the. This is a, if you want to go and see the execution of constructor, you have to use here in this. Don't use step over. Use step into. Then you can see at the time of creating object, automatically constructor is called, and you can clearly see the control is inside constructor. That shows, that tells that whenever object is created, constructor is automatically called. Now you can see here. See, can you see that now? So this definitely creates that object. You can see here that object is shown here. It creates object, and all these variables are created inside this object, book object. That I had discussed a number of times. Right? Next, step over, step over, step over. Fine. Now, if you print book, definitely you can see all that data. Or otherwise, this under special variables, you can see that here somewhere, right? Let's go to the next step. Then you can see that book is created here. See all with all that variables here. That itself it shows that what is that book object is created with, and book object is initialized with all these instance variables. And internally, you can see based on that values we assigned, it choose that that data types as well. You can see here. Got it, friends? So that is the idea. Finally, this is idea about constructor. Now, finally, just step over. You can see the output here. Get book prints all that instance variables. Okay, and we are seeing the output here. This is the idea of what is that, friends? Idea of constructor, and how do we declare a constructor inside class, and how do we define instance variables inside constructor. And we have seen all that. Point one, this is constructor. Point two, inside that what we do, we are initializing instance variables. Point three, we have clearly seen that when object is created, constructor is implicitly called, automatically called, right? That's all, friends. This is the quick idea about constructors. Next, another example, the parameterized constructors. Let's see one more example for parameterized constructors. We can use same example. I'll do one thing. I'll share this with you. So let me share this. Insert, send it. Okay. Next, after that, parameterized constructors. Let's do that now. Okay, let's take one more, or we'll change the same thing. Let that class be same. Little change here is this default constructor. Here, if I should initialize these three instance variables in this constructor, I need three local variables. What is that? One is name, another one is price, another one is the ISBN number. You can see here. So this is syntax. So that the constructor, and we have to pass some parameters. So variable 1, variable 2, variable 3. How many ever you want, that many you can pass in this parenthesis. And whenever you declare local variables in parentheses, they are called parameters. Now we should initialize instance variables. How do you do that? Just take this name here and assign to self.name. Similarly, use price and initialize to price, and usually use ISBN number and initialize ISBN number. We are done. So this is how you can do parameter passing for constructors. So one important thing is we need a parameterized constructor. That is one thing. And those parameters we should initialize to instance variables here. So that's all. Once this is done, so we don't need to make any changes to getbook. That should, we can leave it as is. Let it be like that. Then come to the book object. Now initialize book object with how many variables? With how many values? Three values. So if you should pass values to constructor, that is done through this object, that to this one. Through this object, right, we have to pass three values. If it is method, we pass through method call. If it is constructor, we have to pass values to constructor through object. So here, I need to pass name, suppose something like, okay, Avengers. Book name is Avengers, comma, book price of 2000 rupees, and ISBN number something like 23456 something. So this is how you should pass values to parameterized constructors. We should initialize object. This approach is same in almost every programming language, not just Python. So I hope this is clear, friends. So this is the idea, right? So each object helps us to create different book details. If you create one object, one book details, two objects, suppose let's create one more, right? So this is book. Let's create two or three. Okay. Okay, book. Sorry, friends. So let's take two more objects. Okay. So here you can take something like Avengers 1, some thousand, or you can change that if you want. Okay. So something like 8. Avengers 2, some 1500, some you can change that to some 1500. Okay. And 1, 2, 3, 4, 5, 6, 7, something like that. So this changed to book 2. Okay. So what do you do here? Book 2, book 3. And now book 1 dot get book. Similarly, you can call get book on remaining two objects. Book 2 dot get book, book 3 dot get book, something like this. Okay, so you can make first one as book one. So this is how we can use creating objects and initialize them. Each object represents one book here. Okay, now run this now. Now you can see here we have three different book details. Avengers, Avengers 1, Avengers 2. Right? So this is how, what is that, friends? This is how we can use constructors to initialize instance variables of a class. Okay, and also we can see here, this is how we can initialize object. So this is simple idea about constructors. What are constructors? Types of constructors. How do we use default and parameterized? And what are the important points of constructors? That we have discussed in detail. And important thing is constructors don't return anything. Suppose if you try to return something, they don't return because they are implicitly called by objects. If it is a method, they can return something. So this is the idea. Okay. So let me share this code with you. Okay. This is done. We are done with the constructors topic as well. So we had discussed all these examples and destructor. So what is destructor? This is something like we create destructors. So as the name says, constructors is used to create and initialize objects. Okay. So they are not create, they are used to initialize objects. Destructor is used to perform cleanup operations. That is, if you want to remove unwanted objects from memory, then we use destructors. And this is the syntax. What is that? Instead of init, you put del. You know, we have delete command as well. So here, instead of delete command, we use delete method. Okay, and under that, we have to provide cleanup operations. So generally, why do we need distractors? This is why. Distractor is used to perform garbage collection. And people ask these questions in interviews, friends. Okay, make sure you understand all this. Okay, so these are all interview questions. How do you perform garbage collection in Python? Then we use distractors. And that too, it is used to perform explicit garbage collection. Of course, Python has implicit garbage collection. Even if you don't do garbage collection, it automatically performs garbage collection. What is garbage collection? Removing unwanted objects from memory. Okay, that's what that is here. You can see. And it happens automatically in Python. Just now we just emphasized on these points. And destructor is automatically called once after completing execution of a program. We test it and understand this with clear examples. So again, you don't need to call destructor like constructors. Once after execution of program is over, destructor is automatically called. Okay. An object is eligible for garbage collection if if it doesn't have external references. So once if object don't have external references, then it is garbage collectible object. For example, you see here. So these are all external references, book 1, book 2, book 3. Suppose after that I say that book 1 equal to none. Okay, I set it to none. Then this book 1 is immediately eligible for garbage collection. Why? Because now this object book, which is earlier pointing by book 1, doesn't have any external reference at this stage at line 20. Then this object becomes garbage collectible object. Why? Because we set it to none and this object lost external reference. Suppose I just want to show you with the clear this thing with the in paint. Suppose when we create object, this is the object. We have three variables inside that, some name and something like price and something. Okay, name, and then second one is price, and third one is ISBN number. Okay, this is your object. Don't worry about what is inside that. Now you put some, this has some address definitely, not 100 for sure if it is in code, but for, assume the address is this. Now, what is it? So this address is stored inside that reference variable. Most of us know that, and it sits inside reference. Now this address, this reference is pointing to this object, right? So now at this stage, this object is having external reference. This is external reference. And this object, as long as object has external reference, it is not garbage collectible. What is that? It is not a garbage collectible. When an object is garbage collectible, if object doesn't have external reference, it's no more have external reference. So what is that? You did some book one equal to none. In this case, when you say book one is none, then immediately this whatever the previous reference to this object, this is removed, and now book one is just initialized with what? With none here. Got it right? Now this reference is removed to this object, and this object became garbage collectible because this once we set this book one to none, this object no more have any external references. And if it doesn't have any external references, then this any object, not just this object, any object becomes garbage GC collectible object. Okay, any object becomes GC object, not GC collectible. Already GC in sense garbage collectible. It is as simple as this, friends. It is like holding some object. As long as you hold that, that is yours. Suppose you put somewhere and you just left it, right? Not in your house, somewhere outside. Then automatically anybody can claim that. Even municipality people clean it off. And that is what GC collectible is. As long as someone is there and holding it, it is not collectible. Like if someone takes her, if municipality collects her, anything. Similarly, same thing here. Objects are same. Okay, so this is idea about what is that concept of external reference, and we are talking about destructors here. Okay, so here we can do garbage collection in two ways. That is implicit, which is automatically done by the interpreter. We don't do that. We don't need it exactly. If you ask, right, do you really need garbage collection in Python? We don't need to apply that. Okay. And second thing, another approach is explicit way of doing garbage collection. Garbage collected done by developer by removing reference programmatically. Okay. That is the idea, friends. And in implicit one, what is that? Destructors automatically do this garbage collection. It is called automatically, and it calls all that objects. It try to remove all that objects and reclaim that memory. That's how it works. Got it right, friends? So to implement destructor, what is that? We need this del keyword. If you want to explicitly create constructor, this is a simple example. We can try this. So there is nothing difficult here. Okay, let's do that example. Right click and new, and then destructor demo or test. Okay, so class subtest. Okay, and df underscore underscore del. You can see there the destructor is already there. Just for something, say object destroyed. Okay, and then just create some multiple objects. obj1 equal to test. Again, create multiple objects like this. Okay. obj2, obj3, obj4, obj5, okay, obj6. Let's run this now. Okay, you see that after the execution of all this whole program, okay, you can just do a print here, program ends. Okay, here. Now run this. Once after, see, this is why I put this statement is just to make sure you understand this, friends. Okay, this you can see after executing last statement in program, destructor is called. Okay, friends, see that. See, when destructor is called, not when program is executing. Once after execution of program is over, this is the last statement in program. Once after that is executed, you can see destructor is called. Got it right, friends? So this is the idea. What is the idea? So this is not idea. This is the proof that destructors are called once the execution of program is completed. Okay, so that is a quick example for destructor. Let's share this code snippet with you. Okay. Next after that. So we're done with constructors and destructors. Probably we should be very clear with all that. The next thing is we have to jump to the new topic again, inheritance. Okay. So this completes the is a foundation for OOP, object-oriented programming. People call OOPS, but I don't know what is that test exactly. Honestly, friends. Generally, when saying OOP, people call OOPS, but generally it is just OOP, object-oriented programming. S doesn't have any significance. That is something introduced by Amirpet people. Okay, right? That is the idea. So now we have already discussed static class methods, instance methods, all that. Okay, and we also covered different types of variables. What is that? Now you know different types of variables. Instance variables, okay, static variables, local variables, okay, global variables, okay, and you know all different types of variables now. Got it right, friends. So finally, this ends the foundation for OOP. Now let's jump to the another feature of OOP. What is that? Inheritance. So we know object, we know class. Okay. Now the next topic is inheritance. Abstraction, we'll see that anyhow, no problem. And also one more is encapsulation, making data private. Like in Java or C++, we don't have something exclusive keywords. This is not, we don't have that much of this thing, but I'll show you how to make your data private in Python. I'll show that. Okay, so that abstraction, that encapsulation, how we do that in Python, I'll show all that. But let's continue with next feature, that is inheritance. What is inheritance? Simple, friends. So it's nothing but deriving properties of, now you know classes, right? We have implemented so much of class programming so far. How to declare class and properties inside that, all that. So what is inheritance here? It is nothing but deriving a child class from a superclass, like deriving properties of superclass to a subclass, or a parent class to a child class, or a base class to a derived class. And this is inheritance. The greatest advantage with inheritance is it avoids redundancy of data, right? It avoids data redundancy. If you use functions or methods avoids code redundancy. when you write something, some code again and again, in such cases, we can avoid that code redundancy with methods or functions. And same thing, if you have data redundancy, this is very important, friends. The data redundancy in sense declaring same data again and again, same variables again and again. We can avoid such thing by using this concept of inheritance. What inheritance does? Inheritance avoids data redundancy. That's what it does, friends. Right? What exactly here? What's exactly happening here? We declare all the common properties of subclasses in a class called parent class. We'll see that with a pictorial analysis so that you get a clear picture of inheritance. So all that common properties of child classes or subclasses or derived classes are declared inside one class, and that class is nothing but parent or base or superclass. Classes declared at the bottom level are called as child or sub or derived classes. Okay, and also we can have a proper code maintenance with inheritance. We can break down or modular. We can introduce a proper modularization with inheritance. Got it right, friends? That is the idea. Okay, I'll show you a small scenario how data redundancy is, how we avoid that with inheritance. And these are all different types of inheritance. We can see here single, multiple, multi-level, hierarchical, multiple, and hybrid. Okay, so we'll just see all this one by one. Okay, what is single, what is multi-level, and Python supports all this. If it is Java, Java doesn't support multiple inheritance directly. It is done with interfaces. But in Python, we don't have such issues. Python also supports multiple inheritance as well. Okay. So now this is what happens with inheritance. So suppose you want to display details of some animal or some flower. Okay. So generally, flower has what? Flower has these features. Flower has name, flower has color. Okay. Flower has price. Okay. All these are properties of flower. Suppose if I want to, so there are different flowers, right? So like you can take examples, rose flower or lily or hibiscus. There are so many flowers. So now, suppose you see here, you created one class for rose. Assume that you created one class for rose to display properties of to define and initialize rose details. Again, rose has a name, rose has color, rose has price. Similarly, you have declared one class for hibiscus. What is that? Hibiscus has a name and then it has some color, it has some price. Okay. Similarly, you declare one class for another flower. Let it be lily. Just a quick level analysis. But to define this, we have to use some name, color, and then price. Assume that we don't have inheritance. To represent each type of flower, we need one class. Sorry, friends. So, but if you see inside each of these belong to a class called flowers, definitely. What is that? All these are belonging to a class of flowers. What is that class here? They belong to a class of flowers, which technically we call them as, what is it? We call them as flowers itself. And now we can see same variables are repeated for rose, hibiscus, and lily. And here, how many variables we are defining? Instead of 3, we are defining 9 variables. See, this is what we call redundancy, means a duplication of data, repetition of data. Okay, redundancy. So this we can simplify that by declaring just 3 variables instead of 9 variables. And we can avoid declaring 6 variables if you introduce the concept of inheritance. You got it right, friends? So that is the idea. That is the idea of what adding inheritance to your code, right? So this is by looking at this, you can easily understand. So instead of having a separate class for rose or hibiscus or lily, what you can do, define a class which is common for all these three. What is that? That is something flower. Okay. In this class flower, you define something like name, color, and then price, all that. Whatever you think that is needed. All common properties of all this. Okay. What is that? Common properties of rose, you put inside flower. Common properties hibiscus, you put inside flower. And common properties of lily, put in flower. And this common class becomes this, whatever class you define here, all that class with common properties of these what? Classes, rose and hibiscus and lily. If you put in one class, that is nothing but that is the parent class. A parent class or a super class is a class with all common properties of its child classes or subclasses. And what is the greatest advantage? This time, we just limit our variable declaration just to 3 variables instead of how many variable declarations? 9 variable declarations. We have saved 6 variable declarations. So this is the saving we have. This is the effort we reduced. So this is the advantage with inheritance, friends. You got it right. Understood, friends? What is inheritance? Deriving properties of a parent to child. Actually, I put parent at the bottom, child at the top. It has to be flipped, but the diagram is fine. So I'll just make it much more simpler for you. So what is the UML diagram we should create for OOP? The common class has to be like this. What is the common class? Flower. And you have to define common variables, name, color, and price. And the subclasses should be at the bottom. Something like you can inherit a rose from flower, and that subclass specific properties. Maybe you can add a location because all roses are not in same location. Okay, it might be in some flowers will be grown more in one location. Some flowers are grown more in some other location like that. So just add something subclass specific properties in subclass. Anyhow, all common properties are in the parent class. Similarly, you could put one more thing, hibiscus, and you can add something like something specific to hibiscus. Okay, that you put here. That's subclass specific properties in subclass. And the third one is what is it? Rose, hibiscus, and you can take anything. I'm just taking an example to set understand the scenario. So that lilies are grown extensively in some places that we define here. That subclass specific properties. Now, as per UML, your subclass should be inherited from superclass, and this arrow mark should be pointing upwards, not downwards, friends. Okay, right, like this. Okay, and this is your parent. This is how you have to create inheritance. So these are all subclasses. Okay, this is one subclass, and this is one subclass, and this is one subclass. Okay, and here the advantage we see here is that in the previous examples in the discussion what we had to define 3 different flowers, we need 9 variables. We simplified that with inheritance with just 3 variables. The save is 3 variables, 6 variables. So we are saving a memory of 6 variables with what, friends? With inheritance. So this is the greatest advantage with the inheritance, friends. You got it right. So that's how interesting, right? See. So that is the idea of inheritance. What is redundancy? What is superclass? Here you see the top level class is superclass, bottom level class is subclass. Okay, we can have much more hierarchies. To understand that, we are going to talk about types of inheritance here. So we start with single inheritance. Okay. Single inheritance name says there are so many single, multi-level, hierarchical, multiple, and hybrid. We'll start with single here. What is single inheritance? Deriving one child, one subclass from one parent, one child from one parent. Just it has one subclass. That's all, friends. Let us take this simple example to understand single inheritance. What is the syntax to inherit a superclass to a subclass? Simply, you can see here. This is the syntax. Inside bracket, just pass that parent, whatever that is state to the child. Sorry, friends. Still, I am not completely recovered from this cold and cough. So now continue with this. What is syntax? You have a child class. Simply, if you see, remove this. Assume that you have two classes. Now you in this you put bracket and pass parent to child. Means right now at this stage, if you just define parent and if you just define child, there is no relation between these two classes. No relation. If that relation must be there, that inheritance should be there, then put brackets to child and pass that parent to this. Now this parent and child have relation here. If you just put name a class as parent and another class as child, it doesn't mean that they are parent and child classes. Some relation should exist between them. And how do you do that? Just you can do that just by passing something like this, friends. Okay, some parent. You got it? Now both of these are related. Parent and child are related through this concept of inheritance. Got it right? If it is Java, slightly they use syntactically there will be a slight difference. But concept of OOP is quite common. 80 to 90% of the concept is same. Only change there will be slight syntactical changes in any language. Honestly speaking, if we are really with one language, we are good with any other languages. So that is the idea, friends. So now let's see the example of single inheritance. We'll finish that today and we'll close this session today, okay? Single inheritance. What is single inheritance? You just take a class A as a parent, define just if you want, you can use constructor, or if you want, you can use an instance method for testing purpose. Anything should be fine. Suppose I want to initialize two variables to this object to class A. So how do I do? Underscore underscore some init. I'm using constructor self dot okay, self dot a equal to 10, and then I'm just defining and assigning as, I mean, hard coded static values here. Define declaring two variables a and b, 10 and 20. Okay, this is one thing. Self dot a equal to 10, 20. Now, if you want, you can define one more method to see, get a, to print values of a. If you want, you can use a method, something like print a, print. I'm just printing it. If you want to add some more data description, then you can add that. What is that? So here, I cannot directly call a self dot a and then I can say self dot b here. Okay, like that. So this is about one class, assuming this as parent. I define another class b, which is inherited from a. That is fine. Now I use a method d of, sorry friends, some add. Now what I'm doing is I'm saying self dot a. You can see a is, when I say self dot, you can see that even a inside subclass, right? It is coming through which what, coming through self, because b is a subclass of a. When this relation exists, the advantage with inheritance is the properties. Properties means the variables you define in class, the methods you define in class can be directly used in the subclasses. Can be directly used in the subclasses. You got it right? Without any object creation or anything. I'll show you some interesting insights about this OOP. This is like what is that? Inheritance is a relation, right? B is a subclass of A, or A is a superclass of B. There is one more relation, has a relation. We'll see that after this. We finish inheritance. Interesting. All these are interesting scenarios. You got it right, friends. So this is the idea. So now, as I inherited A to B, you can see when I say self dot A, I'm just doing addition. That addition, to do addition, I am using properties, variables from superclass A. I am not defining anything in my class. I want to find sum of two numbers that I want to do by using variables from superclass A. Then what is that I do? Self dot okay, result equal to, first I'll define result self dot A plus self dot B. And this is a clear observation here. What is that? So this is possible. You can see this class B is directly using properties of A without any object creation or anything, because that is possible because of what? This relationship. This happens even in real life, right? A son can inherit properties of father or grandfather, anything. Same thing here also. But the properties here are just variables and methods. That's all. Okay. So now we did addition here. So what is that I should do? If it is inheritance, recommended is to create object for subclasses. Maybe if you ask me, what if I create object for superclass or parent class A? Nothing happens. If you want, you can create object for A class. But in most of the cases, if you create object for subclass, a subclass have access to all properties of superclass or classes. So through subclass object, we can access properties of subclass as well as its superclasses. Right? That is the idea. Got it right, friends. So now I created a object for B class, and then what is that? Call that get a. If you want to see what variables are there, again B dot call that add method. Okay. You don't need to pass any parameters because we are not initializing this constructor. We are not doing any parameter passing in constructor. So no need of passing values through B class object. Right. So now run this program. What is the output now? You should get a 1020 when you call get a. When you call add, you should get, of course, do a print here. Print. Okay. Just add sum is, okay. Just say self dot that result thing. Okay. Print that. Okay. Right click and then what is that you do? Run it. Then you can see that here. And also you see sometime back, just when we discussed that constructor is automatically called when our object is created, right? Here, which class object is this? B class object. But B class object is implicitly making a call to A class object. See, this is interesting, right? You didn't call A class constructor, but the subclass object even is able to call superclass constructor. That is how that is possible. That is possible through internal chaining of constructor calls. There will be internal chaining of constructor calls. That is how that is done. Put a debugger actually. You do one thing. Put a debugger here. Now run this. You get some idea. Sorry, friends. Okay. At this stage, what is that we have here? Nothing. We just all that infra variables are created here. And you can see it loaded this class A, class B into memory. You can see that here. These are classes, class underscore main A underscore main B. Got it right? So these classes are loaded to memory. Objects are not created. What do you do right now? Say step over, step in. Because if you want to see that jump to the constructor, you should say step into. Now you say step into. See, this is interesting, right? What is happening here? The subclass constructor is jumping into the constructor of superclass. You got it right. So I'll come up with more interesting details on this. This is a really interesting topic, right? We'll discuss much more into the deeper things of this, or otherwise the hidden things of that, the secret things of this. Okay, fine. We'll do that anyhow when we keep doing discussing. Now you can see when I call this, when this object of subclass is created, automatically you can see that is calling constructor of superclass. It's beautiful, right? So now what do you do? Just say step over, step over. This is done. Execution is over. It came back. Now as you are calling get a, because of inheritance, you can see subclass is able to call its superclass method directly as if this method is inside subclass. How that is possible? Because of inheritance again. Like it says, it's very simple, right, friends? As simple as in real life. Suppose a father has a car, son can just take it like that. He don't need to ask for permission or anything, right? So same thing here. Whatever father has, it belongs to son or daughter, right? Same thing here. Even in programming, whatever parent has whatever parent has, all that belongs to subclass except private properties. Except what? Private properties. Right. All other public or protected, all those properties can be inherited. Okay, now anyhow, step over, step over. Okay, and step over. You can see the output here. Interesting. This is idea about inheritance. How a subclass can directly call something from parent as if they were inside subclass. This is all possible because of inheritance, the relationship. Okay, I'm just sharing this code with you. There are so many interesting things about OOP. We will talk it in the upcoming sessions. Okay, not just the concept. So like about what is easy, what is has a, how we implement it, because that helps you to understand the concept of design patterns as well. Okay, at a very deeper level, if somebody is asking you what is all that, at some deeper level, if you want to understand design patterns, all that, all these things helps you. Okay. So that's for today, friends. Anyhow, I'll stop here. We are have already running more than what our time. Should be fine, right? So tomorrow we'll get to that and we'll see the constructor chaining, all that, right? How a superclass constructors are called from subclass, how to call implicitly, explicitly, all that. Okay. Thank you, friends. We'll stop here.